Hello, my dear friends. Anyone in live? Anyone is in live? If anyone is in live, try to text me hi. Try to say me hi. If anyone is in the live, try to say me hi. Hello, Suhas. Hi, hi. Right. Right. Hello. Right. Hi, Murli. Hi. Mm, mm. Right. Uh, Yes. Okay. Hi. Is the video and audio is clear? Yes, I ate. Don't worry. I ate. తిన్నా. Completed my dinner. Everything is done. Hmm. Right. Is the video and audio is clear for everyone? Is the video and the audio is clear for everyone? Right. Right. Okay. I checked the mail. Uh, so I will not respond anything here. We'll see you tomorrow. We'll talk about it tomorrow. Okay, fine. Right. Now we have studied in the last class. We have done up to the preparations of alcohol as well as the preparations of phenol, and preparations of the alcohols and the preparations of the phenols we have done. Now in this lecture we are going to see the what minute. Here we are going to see test for phenols as well as the test for alcohols. Test for the phenols as well as the test for the alcohols we are going to see. Now, what are the test for the phenols and what are the test for the alcohols? But yesterday I was explained one concept, that is on the Remer-Timmer reaction. Based on the Remer-Timmer reaction, I was explained one concept. Now I will do one question based on it. Then after that we'll move to the this today's continuation class. Now yesterday I was did a one question one. Yesterday I was explained the preparations of the phenols. Now in this preparations of the phenol, now the one question. What is the question? One conversion question. Here this is a one sodium phenoxide they have given. Say sodium phenoxide upon CO2 upon. Hello Praneeth, hello. Now this sodium phenoxide upon CO2 upon CO2, clear, it is giving B upon H plus AC2O gives C. Now what is a B and C here? What is a B and what is a C here? In the continuation of the class, CO2 in the presence of NaOH and H2O. What is a B and what is a C here? Sodium phenoxide. These are very important conversions. They are asking in the where they are repeatedly asking. Now here sodium phenoxide plus CO2 in the presence of NaOH and H2O gives B. This B upon H plus AC2O gives C. What is the B and what is the C here? What is the B and what is the C here? What is the B and what is the C here? What is the B and what is the C here? What is the B and what is the C here? If you know, try to say me. If not, give me the question mark. I will explain. Because in the less time we have to cover the more content. If you know the answer, try to say me. If not, give the question mark. I will explain. Should I explain or will you try? Should I explain or will you try? B is phenol. No, no, no. Not B is not phenol. No, no, not the B is not phenol. B is not the phenol. No, Pranit, B is not the phenol. Should I explain? Should I explain? Should I explain? Now, listen. Now this phenoxide ion, here we are having the H2O in the solution. Now due to that H2O in the solution, as the NaOH it will be eliminated and this will become phenol. Actually, this sodium phenoxide ion, now in the presence of H2O, this will be in the presence of which one? OH. Which one? It will be in the presence of phenol. And they have given the CO2 and the base, right? CO2 and the base. CO2 and the base, what it will give? It will give you the salicylic acid, right? Coal-based electrolysis. Yesterday I explained you very clearly. Now this is a salicylic acid. Now B is the salicylic acid. Now salicylic acid upon H plus and the acetic anhydride. This is the acetic anhydride. This is a acetic anhydride. Now this is due to the acetic anhydride. Now what it will happen? Now it will be converted into the which one? It will be converted into the aspirin. Now this is a aspirin, right? So C is the aspirin, B is the salicylic acid. Clear? Orthohydroxybenzoic acid. Done? Is it clear? Is it clear? Still any confusions? No. Right. Right. Now, here now, Prasati, good evening. Okay, right. Now, we'll move to the next concept. Now, in this next concept, now Prasati, yes. Hi, Prasati, good evening. Good evening, Prasati. Good evening. I said your name. Now we are going to see the next concept. That is the next concept that we are going to see. That is electrophilic. Which one? Substitution. Electrophilic substitution reaction of phenol. Now we are going to see the electrophilic substitution reaction of the phenol. Then now the Prasadi, please be focused to the class. Okay. Now, how the electrophilic substitution reactions will be happen? Now, right. The first concept, the first one, we are going to see if suppose phenol they have given, this phenol upon concentrated HNO3, if they have given, and concentrate or dilute HNO3 they have given. Concentrated HNO3 if they have given. Now what is the product? And dilute HNO3 if they have given, and what is the product? This is one, same is the IUPAC name. Now this is a 2, same is the IUPAC name. If you Prasati, you can ask, what is the question you are having? What is the question you are having? You can ask. What is the doubt or what is the question you are having? You can ask. Now, if you know the answer, try to say me. If not, give me the question mark. My dear friends, give me the question mark so that in the less time we can cover the high content. Concentrated HNO3 and the concentrated HNO3. So the first one is nitrobenzene. I mean concentrated HNO3, concentrated H2SO4. Concentrated HNO3 and the concentrated H2SO4 if they have given. First one is nitrobenzene. If the concentrated H2SO4 if they have given, then the concentrated H2SO4 if they have given. The first one is a trinitrophenol. First one is a trinitrophenol. First one is a trinitrophenol because this OH is a strong ortho-para-directing group, right? Now this OH is a strong ortho-para-directing group. Clear? Strong ortho-para-directing group. First one is a trinitrophenol. The second one, name of this compound is a picric acid. Try to remember. This is a picric acid. This is a picric acid. Try to remember. Try to remember this one. This is a picric acid. Now second one, try to say me the answer. Try to say me the answer for the second one. Second one, 2, 4, okay. That is trinitrophenol. I got it. Now I'm asking for the second one. What is the answer for second one? What is the answer for second one? What is the answer for the second one? Sir, then why it is called as electrophilic substitution? What? Electrophilic? Electrophilic substitution reaction. Orthonitrophenol. Should I explain the mechanism? You are asking the mechanism or okay, listen. Now listen. Now the story behind this, how the phenol is giving the orthonitrophenol, I will explain. Here we know phenol, right? This is a phenol. Now phenol in the presence of concentrated HNO3, done, and concentrated H2SO4 if they have given. Now here what it will happen? The better yield of the picric acid is obtained. Here we will get the two types of the paths it will follow. Clear? Now the two types of the path it will follow. Now here what are the two types of the paths it will follow? Because here due to the presence of this strong oxidizing agent, concentrated H2SO4 is a strong oxidizing agent, right? The concentrated H2SO4 strong oxidizing agent, what it will do? It will oxidize the phenol in the benzoquinone in this manner. In this manner, the benzoquinone, it will be converted. Benzoquinone, clear? Now, here, due to the presence of the strong oxidizing agent, this OH, it will be converted into the benzoquinone. Then we will not get the picric acid. We will not get the picric acid. To get the picric acid, we have to follow the two paths. Here, if you directly, if the NO2, if you want to do this, which one? Concentrated H2SO4, it will oxidize the phenol into benzoic acid. Due to that, what we have to do? We have to follow the two paths. What we have to follow? We have to follow the two paths. What are the two paths we have to follow? First, the phenol in the presence of oleum or any H2SO4 or concentrated H2SO4 or the concentrated H2SO4 if you have taken. Now this concentrated H2SO4, what it will do? Now what is the electrophile generated in the sulfonic? Now sulfonic acid reagent or sulfonation, that it is a disulfonic acid is a electrophile, it will be generated, right? Clear? Then this disulfonic acid which has generated, this is separated by the steam distillation. Now this is separated by the steam distillation. We are giving the heat, right? This will be separated by steam distillation. After the steam distillation, what it will happen? We are taking the concentrated HNO3. Then we will get the picric acid. What is the role of doing this one? What is the role of doing the phenol 2,4 disulfonic acid? Because to protect the phenol to not to get into the benzoquinone. So this to not to get oxidized into the benzoquinone, what we are doing? First we are converting into the phenol 2,4 disulfonic acid. Then after that we are doing the nitration. Now we know phenol is a strong ortho-para-directing group. It will increase the electron density at the ortho and para positions very strongly. Is it clear? Is it clear? Is it clear? Is it clear, or still you are having any confusion? Still any confusions, or is it clear? Everyone, is it clear? Okay, done. Then if the dilute HNO3, if they are given, then here we will get the OH, one we will get the ortho nitrophenol and para nitrophenol we will get. Ortho nitrophenol and para nitrophenol we will get. Among the 1 and 2, ortho nitrophenol and the para nitrophenol, may I know which is the more stable? Oh, okay. Now may I know which is more stable? Among the 1 and 2, which is more stable, may I know? Which is the more stable one among the 1 and 2? Para. Now the ortho nitrophenols are separated by the steam distillation. Clear? These are separated by the steam distillation, while the para is less volatile due to the intramolecular hydrogen bonding. This is here the hydrogen bonding will be there. Hydrogen bonding will be there. Ortho hydrogen bonding will be there. Right. Now next another type. Here the next another type we are going to see. If suppose OH they have given, and OH if suppose Br2 H2O they have given, Br2 H2O. Next Br2 in the presence of carbon disulfide if they have given. Now what are the products we'll get? Br2 H2O and Br2 carbon disulfide if they have given. Now, what are the products we will get in the 1 and what are the products we will get it in the 2? What are the products we will get it in the 1 and what are the products we will get it in the 2? What are the products we will get it in the 1 and what are the products we will get it in the 2? What are the products we got in the 1 as well as 2? What are the products we will get it in the 1? So same sir, tribromophenol. Yes, first one is a tribromophenol. This bromine water is used to test for the unsaturation. This bromine water is used to test for the unsaturation. Second one, 2, 4, 6 tribromophenol. Yes, good. 2, 4, 6 tribromophenol. Yes. Next one, orthoparaphenol. Yes, good. Next one is a orthoparaphenol. Yes. Next. Next we'll move to the next. Another type of the reaction we are having. That is phenol and the zinc dust if they have given. Phenol and the zinc dust if they have given. Directly you can remember that phenol and the zinc dust, it will give you the which one? Benzene, and the ZNO it will be formed. This is the one type of the reaction we are having. And the next another type of the reaction we are having. Now acylation, benzylation and the tosylation of the alcohols. Clear? Now already we have seen. Next one, third type of the reaction, oxidation of the phenol. Now remember, this is very important in the conversions. They will ask you this. Remember the reagent, that's it. What is the reagent? Sodium dichromate in the presence of H plus. Clear? Now R, KSO3 taken twice, NO. These are the some reagents we are having. Now these reagents, K2Cr2O7, we know these are the strong oxidizing agent. Now this one we call it as a Fermi salts. Remember, sometimes they may ask in the statement based question also. Fermi salts. Then this Fermi salts, now in this manner, and the double bond O, and this is a double bond O. Clear? This is a double bond O. Phenol turns pink color on the explosion of the air and light. Is it clear? This one we call it as a benzoquinone. This one we call it as a para-benzoquinone. Okay. Now one type of the question I will ask you. Now if you know the answer, try to say me. If you don't know the answer, try to give the question mark. Okay. Try to give the question mark. Now see the question carefully. Now what is the question I was asking? Try to predict the answer. Okay. Try to predict the answer for that question. Now here my question is KMNO4 decolorizes by which? KMNO4 decolorizes by which of the following? By which of the following KMNO4 will be decolorized? Elaya, hi. Okay. Now the option number 1, okay, this is option number 1. Now the option number 2, option number 2, this is a option number 2. Now the option number 3, this is option number 3. Now the option number 4, this is a option number 4. This is a option number 4. Say me the answer. Now in the which case KMnO4 will be decolorized? In which case the KMnO4 will be the decolorized? No, it is not on that basis. Dilute I am not asking. Just base reagent type question only. No, base reagent type question only. Now try to say me the answer. What is the answer? Now try to say me the answer. Answer Elia, you are saying it as a Elia, you are saying it as a Mrudul is saying it as a D. Mrudul is saying it as a D. Good, good. Mrudul, answer is D. Answer is D. Good. Good, no, good. Answer is D. See, indirectly he is asking, we know right, KMnO4 will readily react with the 1 degree alcohol to make it into the carboxylic acid, right? To make it into the carboxylic acid. Now, will the KMnO4 will it react with the, this one is a ketone functional group, right? Will the KMnO4 will it react with the ketone? There is no any acidic hydrogen only. There is no any acidic hydrogen only. Now KMnO4 already this carbon has been oxidized. This carbon has been oxidized already. So it is not having any chance to oxidize this carbon. Now you can see this is a ester. There is no any acidic hydrogen. So this is a ether. This is the ether. There is no any acidic hydrogen only. Now this is a 1 degree alcohol, right? 1 degree alcohol. Now purple color of the KMnO4, when it is reacted with the 1 degree alcohol, it will be converted into the carboxylic acid. This is a very good question. You have to be very careful. This type of the questions, they will stress. See, even though you know the table, but this type of the logical questions, if you don't know, now it will get problem in your exam. So you have to be very clear. Is it clear? Or still you are having any doubts? Still you are having any doubts? Is it clear? Is it clear? Right. Okay, fine. Done. Next. Okay. The next type of the question we are going to see. May I know? I will ask you in the electrophilic aromatic substitution reactions. I will ask you the reaction name. You have to say me the electrophile which is involved here. Okay. First one, nitration. What is the electrophile involved here? Nitration. What is the electrophile? Nitration. What is the electrophile? Next, acylation. What is the electrophile? Done. Next, halogenation. Halogenation. What is the electrophile? Next, alkylation. Alkylation. What is the electrophile? What is the electrophile? Then sulfonation. Then what is the electrophile? Sulfonation, what is the electrophile? Sulfonation, what is the electrophile? Okay, good. Nitration, it is NO2. Okay, fine. For the nitration case, it is NO2. Okay, fine. So next, acylation. 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 Nitration is NO2. NO2 plus. Good. Next, for the acylation, C double bond O plus. Okay. Next, halogenation. 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 Halogenation X plus. Okay, good. Alkylation. Alkylation R plus. Good. Sulfonation. Sulfonation. For the benzene electrophilic aromatic substitution reaction, sulfonation is below 100 degrees only. Below 100 degrees only. For the electrophilic aromatic substitution reaction, it is below 100 degrees only. It is below 100 degrees only. I said you right, neutral SO3 or neutral SO3. Neutral SO3. Electrophile is neutral SO3. Day before yesterday only I explained. No, not. Sulfonation electrophile is neutral SO3, my dear friends. Try to believe this one. This is very important. This is neutral SO3. Neutral SO3 is the electrophile. Okay? Done. Right. Okay, fine. Okay. Now, I hope it is clear the aromatic questions, aromatic electrophilic. Now we'll see the identification test. Identification test for alcohols. Now, identification test for the alcohols. Identification test for the alcohols. In the identification test for the alcohols, first one we are having the can test. What is the meaning of the CAN can test? Can test is nothing but cearic ammonium nitrate test. Cearic ammonium nitrate test. Nitrate test. Now what it will give? Only just color you have to remember. That's it. Now alcohol upon can, what it will give? It will give you the red, pink colors. It will give you the red and pink color. Which one will give you the red and pink color and which one will give you the colorless? Now we'll see. First one, 1 degree alcohol. 1 degree alcohol and 2 degree alcohol and the 3 degree alcohol. 1 degree alcohol, 2 degree alcohol and 3 degree alcohol. 1 degree alcohol upon can, what it will give? Red or pink color. Now 2 degree alcohol upon can, it will give red or pink color. Done. Now 3 degree alcohol, it will give red and pink color. This upon some stand, it will be converted into the aldehyde and it will be the colorless. Okay. Now this 2 degree alcohol, it will be converted into the ketone, then that will also be colorless. Done. Now 3 degree, it will not react. 3 degree, it will not react. Done. Right. Next one, very important test for the alcohols, that is a Lucas test. Very important test that we are having, the Lucas test. Lucas test, OH and in the presence of HCl and anhydrous ZnCl2. Anhydrous ZnCl2. Now this alcohol upon anhydrous ZnCl2, what it will give? Now it will give you the Cl white PPT. Cl white PPT. Now this Cl white PPT. Now which one will give you the instant turbidity? They will ask. Now upon Lucas reagent, upon the Lucas test, which alcohol will give you the instant turbidity? Can anyone? Which alcohol will give you the instant turbidity? May I know which alcohol will give you the instant turbidity? Which alcohol will give you the instant turbidity? 3-degree alcohol. So okay. Then you say me among the which alcohol will give you the instant turbidity. Now you have to say me. Now among the Lucas reagent, 3-degree alcohol will give you the instant turbidity. Next to 2-degree alcohol. Next to 1-degree alcohol. Next to 1-degree alcohol. This it will give you the instant turbidity. Now it will take 5 to 10 minutes. Now it will take several days. Right? Now I will ask you one question. Now you have to say me the answer. Now what is the answer? What is the question he is asking? Here this is a 1. Now this is a 2. Now this is a 3. Among the 1, 2, 3, which one will give you the instant turbidity? Which one will give you the instant turbidity? Order. Among the 1, 2, 3, which one will give you the instant turbidity? Order. Which among the following will give you the instant turbidity and the order? Order I was asking. 1, 2, 3. Yes, because this is benzyl carbocation. This is cyclopropyl methyl carbocation. This is a benzyl carbocation and this is a 2-degree carbocation. No. CPM carbocation. Ah, yes. 1 greater than 2 greater than 3. The one which provides the stable carbocation will react very fastly. The one which provides stable carbocation. The one which provides stable carbocation. The one which provides the stable carbocation. Now with that Lucas reagent will react immediately. Right? Okay, right. Now next. Now the Victor-Meyer test we are having. Now third one is a Victor-Meyer test. Next one we are having the Victor-Meyer's test. Now in this Victor-Meyer's test, only remember the color. No need of remembering the reactions and all. Just remember the color. What is that? First alcohol upon P4I2. P4I2. Then after that P4I2 it will give you A. Now again for this one, again if you do the silver nitrate test, again it will give you the B. And this B upon the HNO2, it will give you the C. Again this C upon the NaOH, it will give you the color. It will give you the color. So what are the color we are having? Int. Just remember. What are the color we will get it by the Victor-Meyer's test? That is, remember RBC. RBC. RBC test. R red for 1 degree alcohol, blue for 2 degree alcohol and 3 for 3 degree alcohol. That's it. What Victor-Meyer's test? What is the color given by the respective alcohol? They will ask. Clear? This is colorless. Sorry. 3 degree alcohol colorless. 1 degree by red, 2 degree by blue, 3 degree by colorless. 3 degree by colorless. Clear? Done? Is it clear? Will you remember? Next one, the very important. The Victor-Meyer test is used to distinguish. The next very important point you have to remember. This is a very important point. They will ask you which one with the Victor-Meyer test is used to distinguish. They will ask, it is used to distinguish. Victor-Meyer test is used to distinguish. Victor-Meyer test is used to distinguish 1 degree, 2 degree and the 3 degree alcohols. 1 degree, 2 degree and the 3 degree alcohols, and 1 degree, 2 degree, 3 degree alkyl halides. Okay, and 1 degree, 2 degree and 3 degree nitroalkanes. Clear? You have to be very careful. These three, we can, with the Victor-Meyer test, we can identify the 1 degree, 2 degree alcohol. We can identify the 1 degree, 2 degree, 3 degree alkali halides, and we can identify the 1 degree, 2 degree, 3 degree nitroalkanes. Is it clear? Done? Will you remember? Right. Next one. The next very important. They will ask you if this concept, if it is clear. Now in the application part or the conversion questions part or any statement based question part, if they ask, you will not get any confusion. Which one? Reaction with metals. Which one? Reaction with metals. Reaction with metals. Now what are the reaction with metals we are having? That is Na, first one. Second one, we are having the sodium amide. Next one, NaOH. Next, sodium carbonate. Okay. Next, sodium bicarbonate. Sodium bicarbonate. Clear? Right? Now, first one we are having the 1 degree alcohol. Will the 1 degree alcohol, will it react with the sodium? Will the 1 degree alcohol, will it react with the sodium? Now say me, will the 1 degree alcohol, will it react with sodium? Will the 1 degree alcohol, will it react with the sodium? Now only one point, key point you have to remember. If the alcohol, if it is reacting with the metal, if the any product generated, if it is more stronger than this alcohol, then the no reaction will be happen. This 1 degree alcohol will be reacted with the, yes, it will react. 1 degree alcohol, this alcohol will react with the sodium metal. Why? Because here it will form RONA plus H2 gas. H2 gas is weaker than the alcohol. H2 gas is weaker than the alcohol, so readily it will be react. Now with the sodium amide also it will be react. No. 2 moles of H2 gas it will be generated. 2 moles of the H2 gas. 2 moles of the H2 gas, that H2 gas will be generated. Due to that alcohol will be react with the sodium metal. This is very important. Now next, here also with the sodium amide also it will be react, because again it will become the RONA and again it will generate the H2 gas. Now, will the alcohol, will it react with the base NaOH? Will it react with the NaOH? Here it will not react with the NaOH. Why? Because here the generated one is H2O. Now with the alcohol, H2O is a more acidic. Compared to the alcohol, H2O is a more acidic, right? Now weak acid one generating the more acid, strong acid is not stable. That's the reason weak acid will not generate the strong acid. Strong acid can generate the weak acid. So that's the reason no reaction. Here also no reaction. Why here the HCO3 minus it will be generated. Next, here also no reaction because here the carbonic acid will be generated. Now this is about the alcohol. Now next we'll see with the phenols. Next we'll see with the phenols. Now, will the phenols will react with the sodium? Yes. Why? It will form the phenoxide ion. It will form the phenoxide ion and it will produce the H2 gas, right? So it will react. It is producing the H2 gas. Now here with the sodium amide also it is producing the H2 gas. It will react. Done. Next one. Will the phenol will it react with the NaOH? Yes, because here whatever the H2O it is providing, now compared to the phenol and the H2O, H2O is a weak acid, so it will react. It will react. Done. Next. Here, now the phenol and the sodium carbonate if it is reacting, here what it will get? Here it will get the sodium bicarbonate. Now this sodium bicarbonate or this bicarbonate ion which is having that it is weaker than the phenol. So here also the reaction will be happen. Same product only will get. Now, but here the reaction will not happen. Last one. Why? Because here it is a carbonic acid. Carbonic acid is a more stronger acid than the phenol. Next, when it comes to the carboxylic acid case. Now, carboxylic acid in all the cases it will be reacted because here the H2, here also H2, here the H2O. Next one, here it is a RCOONA. Now here it will be the which one? Carbonic acid which will be present in CO2 and the H2O case. Now with the carboxylic acid it will react with all. Now carboxylic acid will react with all. Now this carboxylic acid will react with all, and the phenol and the alcohols you have to cross check. Very clearly you have to cross check the which one? Phenol and the alcohol. With the which one it will be react, for the which one it will not react. Is it clear? Is it clear? Or still you are having any confusion? This is clear, right? Right. Now we'll move to the another type of the concept. Or the another type of the concept that we are going to see, that is dienone phenol rearrangement. Dienone phenol rearrangement. Dienone phenol rearrangement. What is the dienone phenol rearrangement? Here the dienone phenol rearrangement. This is the one dienone they have given. Clear? This is the one dienone. Now dienone in the presence of H plus or OH minus, H plus and the OH minus, what it will do? Now here we are having the one acidic hydrogens. Now this acidic hydrogen it will do the tautomerization. Now to here, now this one will be delocalized in this manner. Now to give the phenol. Okay. Now this is a product we'll get. Let's suppose if they have given in this manner. Now H plus and OH minus, and now what is the product IUPAC name? Now same is the product IUPAC name. Okay, better I will give you the, if you are getting confusion means I will give you the CH3L. What is the product IUPAC name? What is the product IUPAC name? What is the product IUPAC name? Can anyone say me the what is the product IUPAC name? Toluene. How come toluene? Para-hydroxytoluene. Nana, my dear Pranit, IUPSC you have said wrong. IUPSC you have said wrong. IUPSC you have said wrong. Among the OH and among the CH3, no, that is among the CH3 and the OH is a high priority, right? This is OH and this is a CH3 and this one we call it as a paracresol. This one we call it as a paracresol. You have to be very careful with this one. This is a paracresol and the name of this one will be the paramethyl phenol. Clear? Paramethyl phenol, because this is a OH is a high priority, or 4-methyl phenol we can say, and the common name for this one is a paracresol. You have to be very careful with this one. Paracresol. This is right. Next one. Next one. Now you see me. If suppose if they have given in this manner. If suppose if they have given in this manner. Now see me. Concentrated H2SO4. Now what is the product you will get? What is the product you will get? And what is the IUPAC name? What is the product you will get and what is the IUPAC name? What is the product and what is the IUPAC name? Or else if you are getting confusion means I will give you the CH3. CH3 3,4 alkyl phenol. Yes, good. 3,4 dialkyl phenol. 3,4 dialkyl phenol. How? Because this phenol itself. Now the mechanism. Now the phenol itself. Now this is a dialkyl. Here the hydride. Here the 1,5 or 1,3 proton transfer, there is no chance. So that's the reason H2SO4 what it will do, it will take this bond pair of electrons towards itself. When it has taken this bond pair of electron towards itself, now oxygen will get the positive charge. Now to stabilize this positive charge, the bond pair of electron will be shifted. Now when this bond pair of electron has been shifted, to stabilize this carbocation, again this bond pair of electron will be shifted here. Now when this bond pair of electron has been shifted, now again it will convert it into the enol. Here you will get the positive charge. Here we are having the dialkyl. Now it will convert into the OH. Done. After converting into the OH, here this one we are having the H. Clear? Now here this 1,2 alkyl transfer will be happened. Now when the 1,2 alkyl transfer it has happened, or now here the positive charge you will get and here the alkali you will get. Now here the alkali we are having, either we are having the H, right? Now this H again it will be restored to the aromatic ring. It will restore to the aromatic ring. So 2,3 diphenyl, so dialkyl phenol. 3,4 dialkyl phenol. Clear? Done? Next. If suppose, right. Right. Now, next one very interesting question I will give you. If suppose if they have given in this manner, upon H plus gives A, A upon selenium and the heating gives B. Okay. B upon pH N2 plus. pH N2 plus NaOH pH maintaining 9.5. pH maintaining 9.5. Now C. Okay. Now what is the C? What is the C? Options I will write you. Options I will write. Try to send me the answers. Okay. Now this is a 1. B. This is a B. Now C. Now this is C. D. None of the above. Now try to say me the answer. Try to say me the answer. Answer is B. Good, good, good. So as good. Answer is B. Because here the now the A is dienone phenol rearrangement. No. Answer is B. No. Answer is B. Answer is B. How? Because here first one, here the first one, here the one cyclopropane ring, cyclopentane ring they have given, right? No, it will abstract the H plus, will abstract the H plus. When it has abstracted that H plus, now oxygen, again what it will get? Again it will become the H plus. How? This pi bond will be shifted here. Then here this carbon will get the positive charge. Then after the carbon, when it is getting the positive charge, now you have to see this is a ring adjacent carbon. Ring adjacent carbon, if it is having the positive charge, what it will happen? Ring expansion will be happen. Now in this manner the ring expansion will be happen. Now after the ring expansion done, after the ring expansion, here we are having the H, right, that it will be given to the aromatic ring. Now and the aromaticity will be restored. After the aromaticity will be restored, then we are having the selenium and the heating. What it will do? It will do the alkanes into the aromatization. We know that it will eliminate the H2O gas. All the H and the H, it will be eliminated and it will give the ketones. And it will be converted into the aromatic ring. Then after converting into the aromatic ring, now this is a, which one? Benzene diazonium chloride, right? Benzene diazonium chloride. Now the benzene diazonium chloride, now this the phenol, it will increase the electron density at ortho. Now this is a meta to the OH, right? This is a meta to the OH. This is a ortho to the OH. So it will go and attack. So the answer is, due to that the answer is B. Okay? Is it clear? Not C. For the OH, this is a meta position. This is meta position, not the ortho position. OH is a ortho paradirectic group, right? No. Next one. Next one. Is it clear or still you are having any confusion? Now I will ask you one question. I will ask you one question for you. Here I will write some questions here. What is a question? Some questions. Questions in the sense I will write some like molecules. Some molecules I will write. Now you have to say me order. Okay, order you have to say me. Like which among the following will be reacted very fastly? Like that. If suppose if they have given among the 1 and 2, which one will react very fastly with AgCl? Which one will be react very fastly with AgCl? Not AgCl. Better will take the KCl or AgCl only will take it. Which one will react with the AgCl very fastly among the 1 and 2? Among the 1 and 2, which one will be react with the AgCl very fastly? Space Prince, sir, even my father likes your teaching. No one thought him like you before he went into IIT Madras. Okay, thank you, Prince. Thank you for your compliment. Now, among the 1 and 2, which is the answer? Suhas, ఏదో ఆన్సర్ చెప్పి delete చేసావు. What is the answer? Thank you, Prince, for your compliment. Right, this is the Ag plus readily this Ag plus ion. This Ag plus ion will produce a stable carbocation, right? Here the carbocation is unstable, so the 2 is more stable. The 2 is more stable. 2 is more stable. And the next one, if suppose yes. If suppose right. Done. No. Among the 1 and 2, which one will be react with the AgCN very fastly? Among the 1 and 2, which one will react with the AgCN very fastly? Among the 1 and 2, which one will react the AgCN very fastly? Oh. No. One will react very fastly. May I know the reason? Why you have chosen the 2? Why you have chosen the 2? Answer is 1. Why? Because here this Ag plus will readily, if this Ag is, if it is eliminated, here we'll get the carbocation, right? Listen, I will explain. Now here, no, here one and here one. Now this is a carbocation, right? Now carbocation, right? No. This is anti-aromatic, right? This is anti-aromatic. And this is non-aromatic. Now among the stability, if you take aromatic greater than non-aromatic greater than anti-aromatic, right? This is right. Aromatic greater than non-aromatic greater than anti-aromatic, right? This is after the Br, if it is eliminated, here it is getting the positive charge. Then it is becoming anti-aromatic. Now here this positive charge, if it is eliminated, then it is becoming non-aromatic. But in the stability, non-aromatic is more stable than the anti-aromatic, right? Carbocation stability, if you cross check, is it clear? Is it clear? Done? Is it clear? Next. Yes, right. Now this is the one compound they have given. This is the one compound they have given. Upon oxidative ozonolysis. Upon oxidative ozonolysis, how many products will get? How many products will get? What are there? How many products will get and what are there? How many products will get and what are there? How many products will get and what are there? What are there? Oxidative ozonolysis. Products of What are there? What are the formic acids? Oxidative ozonolysis I was given. So cross check the answers very fastly. Clear? Now try to be what are the products name? Name. What are the products name? One is ketone. Suhas is saying formic acid is saying ketone is saying. I'm asking stable products name. Okay. I was asking stable. Okay. The question I will mention very clearly. Stable products name. Stable products name. Okay. Stable products name. Stable products name. Stable products name. Go to 3 into 1. Okay. Now we'll see. This is the oxidative ozonolysis, right? Oxidative ozonolysis. If they have not given the zinc means, if the oxidative ozonolysis if they have given, then here we will get the one formaldehyde. One formaldehyde will get 2 moles of the formaldehyde will get, and the another one will get the here the aldehyde. Okay. Now here this compound will get the aldehyde and this one and this compound will get the aldehyde. Okay. Now but we know this is a ozonolysis. Ozonolysis, it will not stop the reaction at the aldehyde stage. It will not stop the reaction at the aldehyde stage. Now, in the formaldehyde upon the ozonolysis, in the oxidative ozonolysis, formaldehyde will be converted into CO2. You have to be very careful with this one. Formaldehyde upon oxidative ozonolysis, it will convert into CO2 and this aldehyde will be converted into the carboxylic acid. It will be converted into the carboxylic acid and this one we call it as a which one? Oxalic acid. You have to be very careful whenever the oxidative ozonolysis they have given. Oxidative ozonolysis, if they have given, the formaldehyde will be converted into the CO2. Now again this whatever the aldehydes it has formed, that it will be converted into the carboxylic acid. So that's the reason I was asking you. This type of the conversion questions you have to be very careful. Is it clear? Is it clear? Is it clear? Okay. Right. Next we'll do some questions. Some questions we'll do so that whatever the misconceptions you are having, that it will be clear for you. Now we'll do some questions so that whatever the misconceptions and whatever the questions you are facing problem, that all it will be become easy for you. Now wait, I will write the one question. Now, okay, right. Here the one question is, first one they have given, this is OH and this is a OMe. Okay, in the presence of concentrated HI. Okay, concentrated HI, it gives B. Okay, this B, we can prepare this B from the first one, KOH 470 Kelvin high pressure. This B we can prepare from the with this reagent also, 1, 2 dibromo benzene. 1, 2 dibromo benzene also, with this help of the reagent we can prepare the B. Now this B we can prepare from the, in this reaction also, H2O2 in the presence of base or H3O plus. H3O plus. Now that is which one? OH, and this is a formaldehyde from the Remer-Timmer reaction, salicylic. So this A, let's suppose this is A, this is C, and this is D. And what is the B here? What is the B here? We can prepare that B from this reaction. We can prepare the B from this reaction. We can prepare the B from this reaction. And what is the B over there? What is the B over there? What is the B over there? Now try to do the answer from your end and try to say me. If you are not getting, now we'll move to the next question. Now everything you know, this is a one beautiful conversion. I will not explain. This is one beautiful conversion. Try to predict the answer by your own. ఇంకో క్వశ్చన్ రాస్తా దానికి ఆన్సర్ ట్రై చేయండి. ఓకే, వన్ క్వశ్చన్ ఐ విల్ రైట్, ట్రై టు ప్రిడిక్ట్ ద ఆన్సర్ ఫర్ ఇట్. దీనికి ఆన్సర్ మీరు ట్రై చేయండి, నాకు చెప్పండి. Do we get diol? No, 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 no. Will not get diol. You are saying that it is a Dakin reaction. From the Dakin reaction, no, 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 no. It is not the Dakin reaction. NaOH, OH, this is a Dakin reaction only. Right. Not this one. This one is a Dakin reaction. This one is a Dakin reaction. This one is a Dakin reaction. Here, coal base upon the high pressure. Now, what is the answer? We will get the diola. Vinith, it is diola. Diola. This is a Dakin reaction. This is a Dakin reaction. Diol ostadi. That we call it as a Chatacol. No, this is the answer. Chatacol is the answer. Good, Nana, good. All కాదు, diol కాదు, diol. OH will get. Good. Right. Good. Next one ఒక చిన్న కన్వర్షన్ క్వశ్చన్. Next one small benzene 1,2 diol, that we call it as a Chatacol. Okay, we'll call it as a Chatacol. Now we will do some questions so that whatever the doubts you are having, it will be clear for you. Search the questions. Right. Okay. I will search one question. Here, one question is there again. Alkene upon P2H6 tetrahydrofuran NaOH, tetrahydrofuran NaOH, done, gives A. This A upon sodium amide, This A upon sodium amide gives B. This B upon alcoholic, not that one. Wait. This is 2 moles of HBr. It will give you alcoholic KOH. Okay? Alcoholic KOH gives C. This C upon Fe red hot tube gives D. D upon NaOH, not D upon X2 FeCl3 gives A, B, C, D, E. This E upon NaOH 623 Kelvin and 200 atm pressure, A, B, C, D, E, F. This F upon this F upon CHCl3 NaOH. Now what is the G name? What is the IUPAC name of G? What is the IUPAC name of G? What is the IUPAC name of the G? What is the IUPAC name of the G? Sir, salicylic acid. And what is the IUPAC name of the, which reaction this is? Reaction name. And what is the F here? You know, one conversion if you get, easily you can identify. One conversion. See, from the hydrocarbons to the alcohols, how they have interlinked. From the where to where they have interlinked, you can see. Now last one is F is a phenol. E is the halobenzene. Yes, good. E is the halobenzene. D is the benzene. Here these two are the red hot two. See, if you want to be success in the organic chemistry, more the questions you do, more you will get. At least one conversion, at least one reagent, if you are able to find, the other easily you can find. Now the last one is which one? Salicylic. This reaction name is which one? Remer-Timmer reaction, right? Remer-Timmer reaction. Now next. Next we'll see some type of the questions. Now one type of the question we'll see. Here the A plus B upon H2O gives C. Okay? A plus B upon H2O gives C. C upon NaOH plus Br2 gives D. Okay? This D upon NaOH plus CaO heating gives benzene. Done? Clear? Now. Done? This D upon NH2 gives E. Now, what is the A, B, C, D and E? Now say me, what is the A, B, C, D, E? 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 So D is benzoic acid. Okay. D is benzoic acid. Okay. Mm. Then what is the C? If the D is benzoic acid, then what is the then if the D is benzoic acid, then what is the E, what is the C, what is the A, what is the B? You are not getting. At least you say me, this is a which reaction? At least you say me, this is a which reaction? ఇక్కడ కార్బాక్సిలిక్ యాసిడ్ రాదు, సాల్ట్ ఆఫ్ కార్బాక్సిలిక్ యాసిడ్ వస్తుంది. దిస్ ఈస్ అ సాల్ట్ ఆఫ్ కార్బాక్సిలిక్ యాసిడ్, రైట్? Now this is a decarboxylation reaction. Decarboxylation reaction, D is this one. D is this one. నేను int చెప్తా, I will say the int. This is a iodoform reaction. This is iodoform. Okay, this is iodoform. Now try to predict the C. ఇక్కడ COH plus CH Br3. Actually, D is having the salt of benzoic acid, and this is a bromo. This is iodoform, right? Iodoform. Sorry, this is bromoform. This is a bromoform. This is bromoform reaction. Like iodoform only, chloroform or alloform you can take. Not iodoform. Here the bromine we are given this. So this is alloform. I means bromoform reaction. This is a bromoform reaction. This is bromoform. Bromoform reaction. Now try to predict the C. Try to predict the A and B. Two products we got. One is a salt of benzoic acid and one is a bromoform. This is a bromoform reaction. Bromoform means the analogous of which one? Alloform or iodoform, we know, right? That only. Now try to predict the C. Should I say? Cheppana nenu? Should I say the answer? Should I say the answer or will you try? Should I say the answer or will you try? మీరు ట్రై చేస్తారా, నేను చెప్పనా? మొత్తం ఆల్ ABCDE చెప్పండి. రివర్స్ నుంచి రా దొరుకుతుంది ఆన్సర్. రివర్స్ నుంచి వస్తే దొరుకుతుంది ఆన్సర్. నౌ యు సీ హియర్, నౌ కమ్స్ హియర్ వాట్ ఈస్ ఆస్కింగ్ acetophenol. Which one is acetophenol? No, there is no any acetophenol here. See, A plus B plus H2O, C plus NaOH plus Br2. This is a bromoform. Or bromoform or alloform. Any compound to show the alloform, what is the main criteria? Okay, no problem. Am I trying? See, whether it is a wrong or whether it is a correct, it is not the matter. Trying is the first priority. In the organic lo evvadu anta topu kaadu. So trying is the first key step. అది తప్పైనా ఒప్పైనా ట్రై చేస్తే మనకి ఏదో ఒకటి అక్కడ ఒక రీజన్ దొరుకుతుంటది. మనం ఏ తప్పు చేయకుండా అసలు ఏమి చేయకుండా కూర్చుంటే మనకి ఏం దొరకదు. సో దాని గురించి మనం డిగ్రేడ్ అవసరం లేదు. దాని గురించి మనకి బాధపడాల్సిన అవసరం లేదు. మనం తప్పు చేస్తేనే మనకి ఆన్సర్ దొరుకుతుంది. ఇక్కడ చూడండి, వాట్ హి హస్ గివెన్, వి నో దిస్ D అపాన్ NaOH ప్లస్ CaO హీటింగ్. ఈ రియేజెంట్ మీకు స్టార్టింగ్ లో కూడా కొత్తనే. దిస్ రియేజెంట్ స్టార్టింగ్ లో మీరు ఎప్పుడు హైడ్రోకార్బన్ చదివినప్పుడు ఈ రియాక్షన్ కొత్తనే. మీరు చదువుతున్న కొద్దీ ఇది ఆల్మోస్ట్ ఒక వన్ మంత్ చూసుంటారు ఈ రియేజెంట్ ని. అందుకు ఇది అలవాటు అయిపోయింది మీకు. డీకార్బాక్సిలేషన్ సార్, ఇక్కడ పక్కా ఏముండాలి మనకి, అక్కడ సాల్ట్ ఆఫ్ కార్బాక్సిలిక్ యాసిడ్ ఉండాలని మీకు ఒక మైండ్ లో ఫిక్స్ అయిపోయింది. సో ఆర్గానిక్ కూడా అంతే. మీరు ఎన్ని క్వశ్చన్లు రోజు చేస్తూ ఉంటారో ఇవి కూడా ఐడోఫామ్ మొన్న చదువుకున్నారు. సో స్టార్టింగ్ కాబట్టి ఇంకొక 2-3 క్వశ్చన్లు కానీ ఇంకొక 3-4 డేస్ అలానే వరుసగా చేస్తే ఇది కూడా మీకు ఫిక్స్ అయిపోతుంది. ఐడోఫామ్ కి మెయిన్ క్రైటీరియా ఏంది, ఎసిటోఫినోన్ ఉండాలి. మెయిన్ క్రైటీరియా ఒకటి ఎసిటోఫినోన్ ఉండాలి. కానీ ఎసిటోఫినోన్ తోని ఏది డీకార్బాక్సిలేషన్ రియాక్షన్ జరగదు. అంతే కదమ్మా. డీకార్బాక్సిలేషన్ రియాక్షన్ కి మనకేముండాలి, సాల్ట్ ఆఫ్ బెంజోయిక్ యాసిడ్ ఉండాలి. సోడియం సాల్ట్ ఆఫ్ బెంజోయిక్ యాసిడ్ ఉండాలి. కానీ ఇక్కడ మనకి బ్రోమోఫామ్ ఆర్ ఐడోఫామ్ ఆర్ బ్రోమోఫామ్ ఆర్ ఆలోఫామ్ జరగాలంటే ఒకటి మెయిన్ క్రైటీరియా ఎసిటోన్ ఉంది అంటే ఇక్కడ జరగదు. అంటే ఇది ఎసిటోన్ కాదని స్ట్రైక్ చేయొచ్చు. దేర్ వీ కెన్ స్ట్రైక్ దిస్, ఇట్ ఈస్ నాట్ ద ఎసిటోన్. దెన్ ఆఫ్టర్ దట్ నెక్స్ట్ క్రైటీరియా వాట్ వీఆర్ హ్యావింగ్, ఐ సెడ్ యూ వన్ థింగ్, ఇఫ్ ఇట్ ఈస్ అ సెకండరీ ఆల్కహాల్ and if it is having the OH, if it is having the secondary alcohol and if it is the OH, then it will be converted into the salt of carboxylic acid and another one will be converted into the bromoform. Now this is the C. What? 1 phenyl ethane 1 ol. 1 phenyl ethane 1 ol, right? This is the which one? This is of C. ఇది C తర్వాత ఇక్కడ H2O ఇచ్చినాడు, A and B అడుగుతున్నాడు. A and B ఏంది, ఇక్కడ మనకి గ్రిగ్నార్డ్ రియేజెంట్. ఇది ఎలా వస్తుంది మనకి, ఎసిటోన్ నుంచి వస్తుంది. ఇక్కడ మెగ్నీషియం బ్రోమైడ్ ప్లస్ 1 ఇస్ అ ఎసిటాల్డిహైడ్. ఒకటి గ్రిగ్నార్డ్ రియేజెంట్, ఒకటి ఎసిటాల్డిహైడ్. ఇది ఇట్లా రివర్స్ డైరెక్షన్ నుంచి వస్తే మనకు దొరుకుతుంది. ఇఫ్ వి కమ్ ఇన్ ద రివర్స్ డైరెక్షన్ వి విల్ గెట్ ద ఆన్సర్. ఇంకో క్వశ్చన్ ఇవ్వనా? విల్ యూ ట్రై? Will you try the answer? Will you try? Okay. ఇంకో క్వశ్చన్ ఇస్తా, లాస్ట్ క్వశ్చన్ ట్రై చేయండి. దిస్ A upon NaOH plus Br2, A upon NaOH Br2 gives B. gives B. B upon coal-based electrolysis. B upon coal-based electrolysis gives N-octane. Gives N-octane. What is the B and what is the A? What is the B and what is the A? వస్తే ట్రై చేయండి, రాకపోతే అడగండి, నేను చెప్తా. A upon NaOH Br2. A upon NaOH Br2. B upon coal-based electrolysis gives N-octane. రివర్స్ డైరెక్షన్ లో రండి అమ్మా, మీకు దొరుకుతుంది ఆన్సర్. రివర్స్ డైరెక్షన్ లో రండి, దొరుకుతుంది ఆన్సర్. ఇఫ్ యూ కమ్ ఇన్ రివర్స్ డైరెక్షన్ యూ విల్ గెట్ ద ఆన్సర్. Sodium butanoate B. Sodium butanoate. Then A. Then A. Sodium butanoate. Butanoate. Butanoate itla. Sodium butanoate itla. Suas. సోడియం బ్యూటనోయేట్ ఏంది, ఎస్టర్ ఎందుకు వచ్చింది అక్కడ? బ్యూటనోయిక్ యాసిడ్. బ్యూటనోయిక్ యాసిడ్ ఎట్లా? బ్యూటనోయిక్ యాసిడ్ కూడా కాదు. బ్యూటనోయిక్ యాసిడ్ కూడా కాదు. బ్యూటనోయిక్ యాసిడ్ కూడా కాదు. సోడియం సాల్ట్ ఆఫ్ బ్యూటనోయిక్ యాసిడ్ కూడా కాదు. సోడియం సాల్ట్ ఆఫ్ బ్యూటనోయిక్ యాసిడ్ కూడా కాదు. ఒకసారి మళ్ళా క్రాస్ చెక్ చేసుకో. వన్స్ అగైన్ యూ క్రాస్ చెక్ ఓవర్ దేర్. మళ్ళా ఒకసారి క్రాస్ చెక్ చేసుకోండి. బ్యూటనోయిక్ యాసిడ్ కాదు. IUPAC నేమ్ రాంగ్. బ్యూటనోయిక్ యాసిడ్ కాదు. అసలు బ్యూటనోయిక్ యాసిడే కాదని చెప్తున్నా నేను. పొటాషియం సాల్ట్, సోడియం సాల్ట్ కాదు. అసలు బ్యూటనోయిక్ యాసిడే కాదు. బ్యూటనోయిక్ యాసిడే కాదు అంటే మీరు చెప్పే IUPAC కాదు. ఒకసారి మళ్ళీ క్రాస్ చెక్ చేసుకోండి, మీరు రాసిన ప్రోడక్ట్ అని అడుగుతున్నా నేను. C+O ఓకేనా? దట్ ఈస్ C+O కరెక్టే, నేను కాదనడం లేదు సార్. C+O C+O ఓకే, కానీ మీరు చెప్తున్న IUPAC రాంగ్ అని అడుగుతున్నా నేను. మీకు ప్రోడక్ట్ వచ్చిందేమో, మీకు అక్కడ పేపర్ మీద అది కరెక్ట్ గానే ఉందేమో, కానీ మై క్వశ్చన్ ఈస్ ద IUPAC విచ్ యు ఆర్ సేయింగ్ ఇట్ ఈస్ రాంగ్. అది బ్యూటనోయిక్ యాసిడ్ కాదు. మీరు ఏదైతే బి చెప్తున్నారో అది బ్యూటనోయిక్ యాసిడ్ కాదు అని నేను అంటున్నా. సార్ డెకేనా? డెకేన్ ఎందుకు వచ్చింది మళ్ళా కొత్తగా? అరే మీకు వచ్చిన ఆన్సర్ వచ్చిన తర్వాత ఎందుకు కన్ఫ్యూజ్ అవుతున్నారమ్మా? మీకు ఆన్సర్ వచ్చింది. ఇక్కడ ఏంది, ఇక్కడ ఏమన్నాడు? ఇప్పుడు కోల్ బేస్ ఎలక్ట్రాలిసిస్ అంటే ఏముండాలి? 2 moles ఆఫ్ సాల్ట్ ఆఫ్ కార్బాక్సిలిక్ యాసిడ్ ఉండాలి కదా, ఇంతే కదా. ఇక్కడ N-octane అన్నాడు. N-octane అంటే 1 2 ఇది 3 ఇది 4, ఇంకొకటి 1 ఇది 2 ఇది 3 ఇది 4. ఇక్కడ 1 2 3 4, ఇక్కడ 1 2 3 1 2 3 4. ఇప్పుడు ఈ రెండింటి మధ్యలో బాండ్ ఫామ్ చేస్తే, ఈ రెండింటి మధ్యలో బాండ్ ఫామ్ చేస్తే 1 2 3 4 5 6 7 8 కదా. ఇట్లా కదా. అంటే ఇక్కడ మనకి ఏముండాలి, 2 moles ఆఫ్ సాల్ట్ ఆఫ్ కార్బాక్సిలిక్ యాసిడ్ కదా. 2 moles ఆఫ్ సాల్ట్ ఆఫ్ కార్బాక్సిలిక్ యాసిడ్ అంటే CH3 CH2 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 ఇదే కదా. C డబుల్ బాండ్ O ఎన్ఏ ఉండాలి కదా. C డబుల్ బాండ్ O ఎన్ఏ ఉండాలి కదా. మరి ఇది పెంటనోయిక్ యాసిడ్ అవుతుంది కదమ్మా. కార్బనైల్ ఫంక్షనల్ గ్రూప్ కూడా మన పేరెంట్ కార్బన్ చైన్ లో ఇంక్లూడ్ చేయాలి కదా. మరి పెంటనోయిక్ యాసిడ్ అవుతుంది, బ్యూటనోయిక్ యాసిడ్ అని ఎలా చెప్తున్నారు. ఇది CO2 వెళ్ళిపోతుంది. ఇక్కడ ఈ 1 mole ఆఫ్ బ్యూటేన్, ఈ 1 mole ఆఫ్ బ్యూటేన్, అనదర్ మోల్ ఆఫ్ బ్యూటేన్ విల్ ఫార్మ్ పెంటనోయిక్ యాసిడ్. నేను అదే చెప్తున్నా అప్పటి నుంచి. కార్బాక్సిలిక్ ఫంక్షనల్ గ్రూప్ ని కూడా కార్బన్ చైన్ లో ఇంక్లూడ్ చేయాలి. బ్యూటనోయిక్ యాసిడ్ అని చెప్తున్నారు. బ్యూటనోయిక్ యాసిడ్ ఎలా అవుతుంది, అది పెంటనోయిక్ యాసిడ్. అది పెంటనోయిక్ యాసిడ్, నాట్ ద బ్యూటనోయిక్ యాసిడ్. ఏ చెప్పండి, ఏ చెప్పండి. బి వచ్చింది కదా. ఏ బి యు గాట్ రైట్. సేమ్ మీద ఏ, సేమ్ మీద ఏ. బి వచ్చింది. ఏ చెప్పండి. ఏ చెప్పండి. వాట్ ఇస్ ద ఏ IUPAC నేమ్? ఫెంటనోలా. ఫెంటనోల్. ఫెంటనోల్ తీసుకుంటే బ్యూటనోయిక్ యాసిడ్ వస్తుంది కదా. 1 2 పెంటేన్ ఓల్ 1 2 3 4 1 2 3 4 5 ఓల్. మరి ఇది ఐడోఫామ్ ఎట్లా ఇస్తుంది? ఎగ్జాక్ట్ పెంటెన్ ఎగ్జాక్ట్ ఓలే. పెంటనోల్ ఇవ్వదు. పెంటనోల్ హౌ ఇట్ విల్ గివ్ యూ ద ఐడోఫామ్? దెర్ ఇస్ నో ఎనీ CH3 అండి. ఎగ్జాక్ట్ ఓలే కరెక్టే ప్రణీత్. ఇది ఐడోఫామ్ ఇవ్వదు కదన్నా. పెంటనోల్ ఇవ్వదు ఐడోఫామ్. అది కరెక్టే. ఎగ్జాక్ట్ ఓలే ఆన్సర్. ఆన్సర్ ఈస్ ఎగ్జాక్ట్ ఓల్ ఓన్లీ. 1 2 3 4 1 2 3 4 5 and it is 6. Now this is the answer. Exent 2 ol only. A is exent 2 ol. మిథైల్ రిక్వైర్డ్. మిథైల్ రిక్వైర్డ్ కదా ఐడోఫామ్ కి. ఇప్పుడు ఆల్కహాల్ ఉంది అంటే ఒక CH3 రిక్వైర్డ్ కదా ఇక్కడ. మరి ఇక్కడ పెంటెన్ 2 ol తో నీకు ఐడోఫామ్ ఎట్లా వస్తుంది? ఐడోఫామే రాదు. అన్ని క్రాస్ చెక్ చేసుకోవాలి. ఒక్కదాంతోనే నువ్వు ఎట్లా చెప్తున్నావు? అన్ని రియాక్షన్స్ క్రాస్ చెక్ చేసుకుంటేనే వస్తుంది. మెల్లమెల్లగా వస్తాయిలే. ఓకే, నౌ బై ఇయర్ I was ending the session. We'll see you tomorrow. రేపు ఈథర్స్. టుమారో విల్ సీ ద ఈథర్స్ అండ్ ఆఫ్టర్ దట్ ఈథర్స్. టుమారో ఇస్ అ ఫ్రైడే రైట్? ఫ్రైడే. ఓకే, టుమారో విల్ సీ ద ఈథర్స్, దెన్ ఫాలోడ్ బై క్వశ్చన్స్ విల్ సీ. ఓకే, ఈథర్స్ చిన్నదే. ఈథర్స్ ఫాలోడ్ బై క్వశ్చన్స్. ఓకేనా? ఓకేనా? విల్ సీ యూ టుమారో. బాయ్. Bye, we'll see you tomorrow. Okay, bye.